in equilibrium? Solid zinc and liquid melt are in equilibrium. So you have solid zinc and liquid melt in equilibrium. Then you have curve CDE. Curve CDE. What are in equilibrium? Solid MgZn2 and liquid melt. So children, can you tell me along curve AC how many phases are there? Along curve AC, how
Two.
many phases? Two phases. How many components are there? How many components are there?
Two.
What are they?
Magnesium and zinc.
Magnesium and zinc.
Magnesium and zinc. Okay, curve DE, how many phases are there? How many phases are there?
Two, ma'am.
Two phases. Very good. And again, components are two. And here, how many phases are there?
Two.
Very good. And components are also two. So along all the curves, you have two phases and two components. So what is the phase rule that you will apply? F is equals to? F is equals to?
F is equal to 2 minus 2 plus 1.
C minus P plus 1. Very good. We are applying the reduced phase rule. So we have two components, two phases. So this implies F is equals to 1. So along the curves, the system is univariant. Along the curves, the system is univariant. Okay. So at the points, this is along the curve. Finish writing, then I will go into the next one. Finish writing, children.
Yes, ma'am.
Yes. Now we will see at the point C and at points C. At point C, how many phases are in equilibrium? Three phases. What are they? Three phases. What are they? They are magnesium, liquid melt, and solid MgZn2. Okay, these are the three phases at point C. Components are two. And point E. Again, you have three phases, but instead of magnesium solid, you have solid zinc, liquid melt, and solid MgZn2. So here also two components. Now calculate the phase rule. What is the phase rule? Two components. Sorry, not two components. You have three components here. Nobody corrected me also. How many components do we have?
3.
Three components. Not three components, children. Components will remain two only. What is
Two
three?
components, ma'am.
Ma'am,
What is
magnesium and
three?
zinc
What is
components.
three?
Phases.
Phases.
Phases. Phases are three. So two components, three phases. So F is equals to
0.
0.
0. So system is invariant at the eutectic point. Okay. At congruent melting point, at D, how many components do we have at D?
2.
No, you have only one component. You have two phases. What is at point D? You have solid MgZn2 and liquid MgZn2. So it's only one component. You have magnesium zinc. It's an intermetallic compound. You do not have magnesium and zinc separately. You have liquid of magnesium zinc, which is molten. So there you cannot separate the thing. So it is there are two phases, solid and liquid, and only one component. Okay. So you apply 1 minus 2 plus 1. Again, this will be 0. System will be invariant. Okay, is that clear? You have only one component at point D, that is the intermetallic compound. Remember, it is the congruent melting point. So the composition at that point will be same. Therefore, you are having only one component. Had it not been a congruent melting point, so then you could then write two components. Is this point clear, children?
Yes, ma'am.
Why are we taking one component? You are right. Liquid melt has magnesium and zinc. That is why we are taking two components. But here there is congruent melting point. That means the composition is same. Because of that, the number of components will become 1. Okay. If no doubts, then I will stop here. Actually, there is one more system left, but in 15 minutes I will not be able to complete. That we will do it in next class. Okay? So you people keep drawing. I will take your attendance in the meanwhile. Vijayalakshmi,
Present, ma'am.
Kevin,
Present, ma'am.
Varshita,
Present, ma'am.
Manish,
Present, ma'am.
Nihal. Nihal is absent.